So the variable that we're trying to solve for in this problem is the final horizontal position. It doesn't have any vertical displacement, it will only have horizontal displacement. And very similar to before, right? I don't have enough, well, I actually need to do my triangle first, then we'll take a look at what information we do and don't have. So the first thing I'm doing is giving myself a right triangle, where the hypotenuse is my combined velocity, 18.5 meters per second. My angle inside here is 48.2. The vertical side of that triangle would represent the vertical part of the initial velocity, and then the horizontal side would represent the horizontal part of the velocity. I'll go ahead and do those two parts underneath the appropriate columns. I don't mind at all if you do that out to the side. If I had more room, I'd probably do it out to the side. So if I do the horizontal first, right, that's the adjacent side of the triangle. So the cosine of 48.2 would equal that adjacent side VH divided by 18.5. And then I can multiply both sides by 18.5. Extra digits here. And can I get confirmation? Somebody else got that too? We'll wait another 10 seconds, then we'll go ahead and do the vertical side. For the vertical side, I'm going to use my sine function. I'll go ahead and fill that into my chart, my columns as well. Just going to erase my sketch. I'm sort of running out of room. Then can I get confirmation on that one from somebody? Yeah. Let me wait 10 seconds before we put something else up there. Questions from anybody while I'm waiting 10 seconds? About splitting that 18.5 meters per second into a horizontal and a vertical part. Yeah,
Why do you write the second V after the other?
The reason I'm writing the second V is to indicate that that's in the vertical direction as opposed to the horizontal direction where I'm putting an H there.
Do we have to? Because I was kind of confusing me, like thinking of it as the horizontal.
Nope, if that's confusing you, don't do it, but I'm gonna keep doing it that way. Alright, what else am I gonna write? Carrie, you have a question or an answer? Alright, go ahead. It really doesn't fit into the table because it's not a horizontal thing, it's not a vertical thing, it's both. So it really doesn't fit into our two columns at all. That's why I kind of do it off to the side. Yeah, Lauren? Right. So I said we're going to put something else in before we try and solve this problem. And Lauren is suggesting the right thing. If we know that the initial vertical velocity is 13.791 meters per second, positive up, then the final is going to be that same speed, but in the downward direction. So I absolutely can do that. And in fact, it might help me out quite a bit if I do that. All right, other issues with now having our three velocities filled into our columns. All right, I'm going to just erase what I've already done to give myself some extra room. What we're ultimately trying to find is the final horizontal position. I don't have enough information horizontally though. I don't have the time. So now I'm going to use vertical stuff to find the amount of time the softball's in the air, and then I should be able to go back to my horizontal side. So just like before, 95% of the time, if you don't know how long the thing's in the air, you're going to have to do that. I am not going to use the big long df equation. That actually won't yield an answer. what I can use is my VF equals VI plus A TF equation, right? Because I know the final velocity vertically is negative 13.791. And then the initial vertical velocity is positive 13.791 plus. Oops, not an equal, it's plus. The acceleration is negative 9.81. And we still have our TF there. So that's going to be a pretty direct method to get that TF. I'd have to subtract this 13.791 from both sides. And then divide both sides by negative 9.81. So it's in the air for a little less than 3 seconds. We do a 15-second timeout before we finish this problem up. Follow-up questions from anybody about using my vertical things to find how much time the softball was in the air? Alright, so now I think I have enough information to solve what I was trying to find, right? And I'm going to use the only equation I really ever use in the horizontal direction. The average velocity is the displacement over the time interval, right? The horizontal velocity stays constant, that's 12.331. Final horizontal position is what we're trying to solve for, and the time we just found. So I can get rid of my zeros next would be a good next step. And then my final step would be multiplying both sides by the 2.8116. Like 34.7. Getting a couple of nods, but I'm unconvinced that anybody else got that yet. Where is that if we're on like a softball field? Where is like 35 meters away? Infield, outfield, home run? Like 100 feet. Just made it to the outfield. Right, so I mean it's legitimate. It's not a hit you want to do. It sounds like you want to do more than 18.5 meters per second. But you know, it's realistic. It's not centimeters, it's not kilometers, it's realistic. So there's an example, right? I think it's, well, there are other questions about what do we have to do? We have to split this initial velocity into components. We had to then treat this like the projectile problems from last week. We had to use one direction to find the time, and then once we had the time, we could solve for what we wanted to find. Other questions about our process for that? Alright, so let me get you working in your foursomes. Now, where do we go from here? We're not going to do anything else new.